Hello, welcome to part 3 of the chats about dividers. This time doing a couple of examples, and both of these examples were taken directly from quiz app questions, so it's the kind of thing you're likely to have to get to grips with. First one is a potential dividers problem, and it looks like this. Now, we can apply exactly the same formula as usual, although note that we're not now being asked what the output voltage is, we're being asked the value of one of the resistors. One of the things you have to do first with problems like this is to recognise that it is a potential divider. It's not drawn in the standard way that we've seen potential dividers before, but it is functionally equivalent, as we can see if we move some of the components around a bit. Maybe the best way to illustrate this is actually to do it in the simulator. Okay, here is the topology of the circuit that we're being asked to solve. And we can perhaps see that it is a potential divider if I start moving some of these things around. If I just take that resistor and rotate it like this, I have to move up that terminal to about there, and that was connected to there. And then move this resistor all the way across here. Make sure it's connected to the same points in the circuit. And this voltage source up to there. And you can begin to see, perhaps, that it actually was, topographically at least, exactly the same circuit as we had before. It's a voltage source that causes a current to flow down through two resistors in series, and the voltage in between the two resistors is either known or that's what we're trying to work out. Okay, back to the circuit itself and the problem. We can apply our potential divider equation, which tells us that V out equals V in times the resistance between the output and ground, which I'll call R2, divided by R1 plus R2. In this case here, we know V out. V out is being measured by this voltmeter. It's 519.7 millivolts. We know V in. V in is what's coming from this voltage cell here, 3.5 volts at this point in the circuit. R2 is the resistor between the output voltage and ground. Currently that is unknown. We don't know it. I'll just call it question mark for now. Divided by the sum of the two resistors. That is a 39k resistor plus unknown. So all we have to do is solve this equation for the unknown resistor. Multiply up, that would give me, well, I'm going to run out of paper if I do it that way, 519.7 milli times 39k plus 519.7 milli times question mark equals 3.5 times question mark. Therefore, 3.5 minus 0.5197, which is 519 milli, times question mark, must be 519.7 milli times 39k, and therefore, question mark, the unknown resistor, 519.7 milli times 39k divided by 3.5 minus 0.5197. That's it. Then all we have to do is put that into a calculator and we can work out the answer. Let's have a go. 519.7 milli is 0.5197 times 39k is 39,000 divided by 3.5 minus 0.5197 is 6, just a little bit over 6.8k. Due to the fact that the output voltage here is only specified to 4 significant figures, I suspect that the actual answer is 6.8k, which I'd normally write as 6k8, because that is a standard resistance value, and the quiz app tends to pick standard resistance values when it can. Right, so that's an example of a potential divider problem. Let's have a look at a current divider problem. Here. Now this is perhaps a more straightforward one because you're told the values of both of the resistors. All we have to do is work out an unknown current, and we can directly apply the current divider formula to do that. An unknown current is the total input current, in this case 4 milliamps, times the other resistor, the resistor that the current that I'm interested in, I1, is not flowing through, 2K, divided by the total resistance, which in this case is 2K plus 500 ohms, which is 2.5K, which I'd normally write as 2K5. Means the same thing as 2.5K, 2,500. And then all I have to do is work that out. 4 milli is 4 divided by 1,000 times 2,000. I'm being a bit silly there. I could have just written that as 4 times 2. Never mind. And divide that by 2,500. Answer 3.2 times 10 to the power of minus 3, which is 3.2 milliamps. Answer. The quiz app will give you an almost infinite array of questions, varying from this one, which is quite straightforward, to some really slightly more confusing ones up at level 4. Do have a go. But those are the only examples that I'm going to talk about at this time. The rest of them I'll leave to you. Next time we'll have a look at an application of the potential divider, the problem of circuit loading.